Okay,
All right.
Stephen, go ahead.
Yep, we're recording, so I'll go ahead and start the webinar and get us up on YouTube.
Thank you.
Yep. All right.
Good evening, everyone, and welcome to Out of the Woods, Growing Income from Your Forest. Thanks for joining us. My name is Lindsay Kozarek, and I will be your host for this evening's presentation. I'm joined by my co-host, Casey Weathers, who will be helping out on tech, and we have two great guest presenters joining us this evening. Before I get started, a few housekeeping items. The chat and Q&A box will be open throughout the presentation. So if you have a question, please feel free to add that there. Or if you just have a comment that you would like to add to the presentation, we always welcome those. We will get to our questions at the end of the presentation. So please hang tight until the end of the presentation where we'll answer those. So let me introduce our presenters for this evening. We're joined by Sarah Collins Simmons, who is the program manager here at Future Generations University for the Appalachian program. Sarah grew up in the mountains of Nelson County, Virginia, so she felt right at home when she moved to Highland in 2011 to participate as one of the founding fellows at the Allegheny Mountain Institute. Sarah studied architecture and environmental science at the University of Virginia. She earned a master's of landscape architecture from the University of Georgia, worked in community development at the Highland Center, and managed orchards and made cider with Big Fish Cider Company. At Future Generations University, she is the program manager for the nature-based enterprises team, working to advance maple and walnut syrup production in Appalachia and expand the region's forest farming. Sarah lives in Bluegrass, Virginia with her husband Joshua, the county's building and zoning official. Excuse me. Their sons Everett and Eliber, and a farm menagerie, including dogs and goats. Together, the family enjoys renovating houses and spending time outside gardening, hiking, and camping. Sarah also makes pottery, jewelry, and baskets. Our second guest speaker this evening is Luke Taylor-Ide. He is our Vice President of Community Engagement here at Future Generations University. Luke Taylor serves as the Vice President of the Community Engagement Division at Future Generations University. He leads the university's worldwide network of participatory action research partnerships. Taylor-Ide has led multi-year assignments with Future Generations in Afghanistan, China, Tibet, India, and Nepal. Taylor-Ide started Future Generations Appalachian program in 2016 to help landowners find new economic opportunities through sustainable forest use. His current research activities center on the intersection between agroforestry, agritourism, and food systems to find sustainable local solutions to the socio-environmental economic polycrises of climate change. So without further ado, I'm going to turn things over to Luke and Sarah.
Thank you, Lindsay, and thank you everybody for joining us this evening. I'm personally very excited to be here because, as Lindsay just mentioned, I started the Appalachian program a number of years ago, and at that time there were really about 3 of us. And so as I've watched this webinar series Out of the Woods grow over the years, and we've had so many fabulous presenters, I myself have never gotten to come on the webinar aside from being a participant. So personally, I'm really excited to be here. So what we're going to be discussing tonight is American sycamore sap and syrup, as well as the tree itself. And really, this is going to be a conversation and a story more than anything about some experiments we started a number of years ago. And at this point, we know a little bit about sycamore, but there's still a whole lot we don't. And so I think that's, equally telling as you start to look at a new industry, and really sycamore syrup is very much a new industry. So before we get started, just a quick word about the university. Most folks on this webinar probably know a little bit about us, but a lot of people don't know that we started as a university and as an institution as a research group and really looking at the question of what are the conditions for sustainable impact in community. That work has expanded. It's gone into some really interesting conservation, peace, and health work around the world. And so we were so excited in 2016 to start the Appalachian program, and our work in the Appalachian region has really focused on that same question of trying to create sustainable impact, and specifically sustainable economic impact for West Virginia and for the region. And so it's important to note that as we've approached the questions, both with maple and black walnut, as Sarah works very actively on, but also our journey into sycamore syrup has started with that lens. How can we conserve? How can we preserve a natural resource? But also, how can we generate income for our farmers? And so with that, let me turn it over to Sarah, who's going to tell us a bit more about just the tree physiology and some background on why the environmental aspects of the tree before we actually get into the tapping and extraction part.
I'm going to start with, if we are interrupted by small children, I apologize in advance. They are in my house, and while I have closed my office door, it does not guarantee that they will not find me. So about sycamore trees, sycamores are one of the largest based on diameter, North American hardwood trees. So they are considered a hardwood. Like red maple, they are a softer hardwood, but they are still classified as a hardwood. They tend to have a bit of a pithy sapwood, but the heartwood is a hardwood and is used in fine cabinetry and some other applied fine woodworking applications. They're a primary and intermediate succession tree. They grow in moist, well-drained soils, so alluvial areas and riparian ecosystems. So that you tend to find them in river bottoms throughout the eastern U.S. And that's like really from the plains east to the East Coast, pretty much north from as far north as the Canadian border down through Georgia and northern Alabama. They are fast growing, which is part of what makes them a successful primary succession tree. And they readily propagate from seed, which is wind dispersed and water dispersed. And then they also transplant. They will grow back from stump and root sprouts. So they want to be part of that riparian changing landscape, and are ready to be tree canopy in those spaces. They also develop a widespread and deep, strongly branched root system, which makes them very resilient to floodwaters, and is part of why they're so successful over other tree species in those riparian zones. Next slide. So I've mentioned the word riparian several times. Riparian is the ecosystem basically between water and always dry soil. So another term for it is floodplain ecosystem. Sycamores are one of the trees that are found throughout the U.S. In riparian zones, and their primary ecosystem function is as a stabilizing factor in those areas. So they hold rocks and soil in place during seasonal or regular flood events. They can withstand weeks of being inundated with water following those flood events. Seedlings can even survive full submersion, and the seedlings tend to be very flexible. Like the plant itself tends to be very flexible, and sometimes you'll see them growing on smaller islands or rock outcrop, like rocky bars in a medium sized river or large sized river. And during flood events, those seedlings can actually be like fully submerged, and they'll actually be just flexing under the force of floodwaters, and then they'll pop right back up. They also are a really important they have a really important ecosystem function for wildlife habitat and food sources. So if you've ever seen sycamores, they have this kind of puffball of seeds. It's a dry ball, and if you kind of mess with it, it is very fluffy. I'm sorry, I don't have a better word right now. But it's called a syncarp, and they stay on the trees. It's one of the identifying factors of the tree. They stay on the tree through the winter, and they're actually a really important late winter food source for a number of native finch species. So birds are part of the propagation system for spreading those seeds, but the sycamores evolved in partnership with the finches to be a food source, a late winter food source for finches, which are a seed-eating species or genus. And then because of the physical structure of the trees, and that they can become hollow, they are important as nest sites and shelter, even dens for animals as large as black bears. So, yeah, next slide. As I mentioned, they are a hardwood species. Unfortunately, most often they're monetized as pulpwood, which is too bad because they have a high value in certain applications. So the way the grain grows, it has a tendency to cause warping when the wood is plain sawn. So that's the kind of normal, just basically sawn. The logs are sawn like this, but if it's quarter sawn, which is an older style or a more complex style of cutting the log, they actually have this really the grain allows them to be really stable, and you can cut thinner pieces and they'll stay intact. And so it's a fairly dense grain, and so they're good for turning. They're good for butcher blocks, but more than that, as you can see in the middle image on this slide, that grain has some real beautiful figure to it, and they're prized by cabinet makers and furniture makers for that pattern and coloration. But that same pattern and coloration makes it difficult to split for things like firewood. And so if I want to keep landowners make them aware that if you're cutting down a sycamore, if you have a way to process it as a quarter sawn boards and to dry the lumber that you can almost guaranteedly sell them to sell those boards to woodworkers. Next slide.
All right. Well, I will jump in here and present on the next couple slides because, as Sarah mentioned, I don't know about most people on this webinar, but I historically had just always passed by sycamores. I never, I think, really paid that much attention to them. Now I notice them everywhere I go, and they really are everywhere you go in West Virginia. Just look in any stream bed, and especially for those white tops, you'll see them everywhere. And as Sarah was mentioning, they're really important habitat species, not only for animals and bugs and insects and birds and all of the wildlife, but also for people, because they have that critical function of growing and holding riverbeds in place for flood prevention. So there's a lot of reasons not to cut down your sycamores, and there's unfortunately not enough mills that will actually do that. So a lot of folks won't pay to come in. It's very hard to find a place to process your sycamore wood. So when we were first getting started doing some of our early maple work, we were running a workshop in the southern portion of the state, and we were talking about the fact that you could make syrup out of not only sugar maple but red maple. You could also make it out of birch, which they do more a fair amount of in New England, walnut. And a lady in the back of the room said, well, my grandfather used to make sycamore syrup. And for Mike Racklin and myself, that was the first time we had ever heard of sycamore syrup being produced. And so we got back with some questions, and we were about midway, I think it was early in the season in 2018. And so Mike Racklin, who's been featured many times on this webinar, Dr. Mike Racklin, I hope he's here with us this evening, asked me and said, well, you've got sycamores on your family property. Can we tap them? And so we did some early experimentation in 2018, really to ask one basic question: is it actually possible to make sycamore syrup? And the answer to that was yes, it was definitely possible. And we learned some things pretty much in the first week or two we were experimenting. And experimentation is what that 2018 season would need to be described as. It was certainly not research. We discovered early on that vacuum made a huge difference, artificial vacuum. We also found out it had a very low sugar content in the sap. And I'll say more about that. But on the highest sycamore sap I've ever seen is 1%. So it often can get down even 0.5%. And so it's a lot of boiling time. And so a reverse osmosis unit, we realized was going to be really essential to making any actual syrup. We also ran into the problem that by the time we figured out those first two things, it was late in the season, and the syrup we made really didn't taste that good. So it was a lot of work, and then the product on the end of all of that work didn't really taste that great, but we had figured out it was possible to make it. Then in 2000, and at that point, we moved our attentions really over to walnut syrup. We were doing that in other locations, and we didn't do anything with sycamore for 1 or 2 years. But then during COVID, I live on the property next door to where we have the sycamore research. I started to think about it and said, well, we should really try to experiment more and learn a little bit more. I don't have any maple trees and I don't have any walnut trees. So the other issue is I wanted to make syrup. So in 2021, we repeated the experiment we'd done in 2018. In terms of the setup, we tapped the same trees. We also added a bag study, and I'll say more about that, but instead of putting them on lines, what happens if you just would put them on bags or buckets? And then I also ended up creating Maple More, which is a blend of maple and sycamore syrup. And that addressed one of the big questions, which was, do people like it? Because while there is a portion, maybe about, I'd say 40% of people who try Sycamore syrup really like it in its raw form. But Maplemore, the blended syrup, is very, very popular. It really tastes like a maple molasses. So in 21, that's what we did, and I'll show you some of those results. Then based on that work in 2021, we were able to get some funding from Northeast SARE, which is an agency of the Department of Agriculture. We were able to bring on some partner farmers who also began to experiment with Sycamore production, and we'll see some of those results in a minute. And we started to really, as a result of having that additional funding, we started to standardize the process. And so we started to move really from just experimenting to doing some actual research. And that work has then continued now for the past few years with some private foundation support. So over the years, I get a lot of questions about how do you do it? What's your approach? And so hopefully, I'm assuming that most participants on this webinar tonight are at least familiar with the basics of tapping. So if you have questions, there's no bad question, but some of this gets quickly into syrup making lingo. So in terms of tubing, the first year we did a 5/16 tubing. We used a 5/16 drop. We used a 5/16 white max flow spile that's made by CDL. And then we did not take daily sap readings of the sugar content in the sap that first year. We did do a basic bag study, and our big takeaway was vacuum was essential. In 2021, we switched over to a 3/16 lateral, and but kept a 5/16 drop. We moved to the CDL Signature Clear spile, which is a different material, but it's the same size as we'd used the year before. We started doing daily sugar readings, which is why I can so emphatically tell you, you will never see more than 1% on a Sycamore tree, or if you do, I'd really like to know the conditions by which it occurred. We repeated the bag study, and just in terms of season notes, we did add a pressure gauge at the end of the line, which helped us start to figure out some of the engineering a little bit better. But unfortunately, I ended up using a really old evaporator, so I will say the syrup that year didn't come out the best. In 22, we then, and this was intentional, we reused the tubing from the year before, which is a standard practice when you make maple, and we did not sanitize it. We wanted to just see what would happen if you left the tubing up. And so at that point, we used new spiles, but everything else was just reused. And I took both morning and evening sugar readings. Bag study was repeated. That year, we had terrible production. The lines were pretty much totally clogged up halfway through the season, and the little bit of syrup I made tasted really, really off, even on a newer evaporator. So in 2023, we then went back to what we did in 21, and basically repeated that again. We dropped the bag study because we were getting at that point really conclusive repeat results on that. And I will say that I had some issues with clogging, and we also had a real warm spell that year. So given how small the research line is, we retapped to extend our season, and we also changed out our drops. So that I'm sure affected overall collection from the year, but we were really at that point focused on seeing what would happen if we did that, because it was becoming still in 2023, we were trying to figure out if there was a late run on Sycamore. Does it suddenly have a run at the end of March, maybe due to root pressure? And we haven't seen that. That didn't really seem to work. It looks like Sycamore follows essentially the same trend as maple when it comes to sap flow. In 24, we repeated the design that we'd used in 23 and 21, with one major change. And that is that we went from a 5/16 tap up to a bigger 7/16 tap because of some work we'd done on walnut. We discovered that walnuts like a bigger tap. And so with that knowledge in hand, I took the same commercial tap that we've been recommending to people to use on a walnut tree, and I put it on a sycamore tree. 2020, that really seemed to work. Okay. I will say that was the first year I got a new pump that year. And so that could have thrown our collection data. But just if you look at overall collection, 2024 really, it was a good collection year anyway, but I was getting a lot more sap per tap that year with the switch to the bigger spile. And so in this past season, we changed up the research design and we put up 2 parallel lines. So each line had less overall taps on them, but and we were then able, and we got another pump. Pumps were exactly the same size. So on the setup this year, the tubing was all the same size. The drops were the same size. The only thing that was different on those 2 lines was that one had a 7/16 size research tap that we've been experimentally designing for the walnut tree. And we can show you one of those a little bit later in the presentation. On the other line, we used just the regular 5/16 polycarbonate spout made by CDL. And the question was there a noticeable difference on those 2 lines? And I won't give away the result because we've got some fun data to show you on that later. As I've mentioned, if you're thinking of making sycamore syrup, you're going to need vacuum. I have seldom seen sycamore sites that I think could create natural vacuum. I'd be very interested to try that. Where my location is, there are places where my lines are just really flat. The ground is flat. And so both for that, as well as it's very clear that vacuum makes a noticeable difference on the tree. And one reason we know that is because I've talked to a lot of people who said, well, I tried to tap a sycamore tree a few years ago and it didn't work. And in most cases, that's because people are putting buckets or bags onto trees. And we've seen that the tree, it needs some kind of vacuum to really perform. So here you can see we had 7 bags hung on different trees in 2021. And first, I'll just note, we're measuring it by the fluid ounce here. You know, if maple sap, you would be measuring it by the gallon. And so when you have to go down to the fluid ounce to get any kind of data at all, your results are just generally very, very low. We did have that bag number 7. I don't know what was that tree's deal because it actually did put out some real noticeable sap on a few days. But overall, if you looked at those numbers, it didn't seem viable. This goes back to my point about we're not just doing this research to figure out if it works. I mean, we like finding those answers. We also want to figure out what we could tell a landowner in terms of how they can use their trees. And so what we say is if you want to make sycamore on your land, invest in a vacuum pump. That's going to be a base cost. Don't even waste your time with buckets or bags. A few factors just for those people who really like the tech side of this. You can see a picture of our basic pump setup. It's got a temperature control on it. It's a SureFlow diaphragm pump, very easy to use, and is extremely reliable. The reuse of lines in 2022 just didn't work. We do Trevor, my friend Trevor, and you'll be seeing some of his data in a few minutes, reuses his lines, but he sanitizes. So there's a lot we need to learn about sanitization and what's clogging these, but that was a big issue, and still is an issue for me, especially on the 3/16. I didn't have nearly as much issue this past year when I switched to 5/16 tubing. In 2023, some of our total data kind of was a wash because of the way the season was. We had some equipment problems. And I will say that in 2024, the real goal was to test the 7/16 spile, but on day one, my pump broke. And so we got the new pump. And I've always wondered if the reason I got such good collection in 2024 was truly just because of the 7/16 spile, or if the brand new pump contributed to that. All right, Sarah, over to you to talk a bit more about the research design that we used here.
Yeah, so we wanted to take this quote unquote sycamore sugar bush that we feel like we've gotten to know pretty well, and put a whole nother layer of data into it by we actually ran 2 separate lines, so that we could, and they're more or less balanced, and we separated it into, so there's, instead of the 29 taps that we've previously had on a single line, we did 2 separate lines, and they basically ran the same length, so they kind of ran almost parallel to one another, in space, and kind of would pick up alternating trees along the riverbank. There are 13 taps per line, and on both lines we're using 5/16 tubing for the lateral, the actual line, as well as the drops. We have 2 separate diaphragm pumps with temperature controllers. The temperature controllers are a little bit different on each of them, but they function the same. So we have SureFlow diaphragm pumps on both systems. But then we have a mountain maple controller on one line, and an Inkbird controller on another. The mountain maple, unfortunately, the gentleman that was doing, the engineer that was, this is a one-man show, but the guy that was doing, that owned mountain maple, passed away, and so we were not able to get a new mountain maple controller built for us. And so we went with a kind of more MacGyvered system, but it's one that is being used out there a lot, and it is inside an igloo cooler, or a polycarbonate cooler, an insulated cooler. You don't want to do high dollar because you're going to drill holes in it, but we have a cooler, and we have the pump inside that, and then we have a heating pad that helps keep that warm when we need it to stay warm, so that our pump doesn't freeze. And then we have an Inkbird controller, which is a fairly low dollar temperature controller, and all it's doing is switching the pump on and off. So we don't get some of the data that we get out of the mountain maple controller, but the function is the same, and we have the temperature settings the same on those 2. So that really wasn't a difference in the collection systems, even though they were slightly different setups. There was no obvious clogging with the 5/16 tubing, which was a huge improvement on previous years in this sugar bush. So we had our 2 different spiles, and we had the CDL polycarbonate spile, which was a 5/16 spile, and then we have the 7/16 experimental polycarb walnut spile that we actually designed in partnership with Marshall Advanced Manufacturing. And essentially the 7/16, it's a slightly larger hole. In all likelihood, we are creating somewhat more non-conductive wood, But what we're seeing is that that slightly larger hole is producing almost double or more than double what the 5/16 polycarbonate spile from CDL is. And Luke's got pictures of the two.
Yeah. So this is the traditional. There's a very common tap. Many in the maple community. This is the 5/16 CDL polycarb spile. And then this is the 7/16 polycarbonate walnut spile, which, as you can see, not only is it a bigger diameter, it's been designed. And Sarah, do you want to say a bit about that design?
Yeah, so which I'll start off with saying, we don't have the same problem in sycamore that we see in walnut. With walnut, you have a really pretty thick bark and then a fairly thin sapwood. With sycamore, the way we understand the physiology is that we actually have a fairly thick sapwood layer, which may be why this is really a great fit. But that with walnut, we're trying to tap into this narrow sapwood layer, but we have this thick bark, and the traditional 7/16 tap that comes from the maple industry does not work the best in walnut because the bark is so thick that it actually starts pushing out the spile throughout the season. And so you have to like tighten up your spouts throughout the season. It's really prone to leakage. And we're not seeing that. We're seeing this new tap really kind of lock in a lot better. And it's because it's got a longer bore. And while that's not necessarily a problem that we're seeing in sycamore bark is not thick like walnut bark is, but it did seem to lock into the sycamore physiology better than some of the other taps that we've tried in sycamore.
Well, definitely. What I noticed when I did the regular black polycarb CDL 7/16 spile, and I don't have one of those to show, but that's the spile that I used with a lot of success in 2024. I did notice that they seem to loosen up throughout the season, and I don't know why that is. We're not going to really hazard a guess, but it could have been the material, it could have been the shape. But knowing that we had this other experimental tap, we decided to give it a try on sycamore.
Yeah, so the black tap from CDL is a nylon tap, and so it's a different material, and the polycarbonate just seems to work better in sycamore.
Exactly.
So these are our two research partners currently on this project. The one is Hillsborough Maple Works, which is in Pocahontas County in the town of Hillsborough, south of Marlinton. So that's on the lower left corner. And then the dotted line is the state border between Virginia and West Virginia. And then McCoy's Mill, which is where Luke is located, is outside of the town of Franklin along the Potomac River. And Hillsborough Maple Works, their Sycamore site is on Stomping Creek, which is a tributary into the Greenbrier, and they're collecting near the mouth of that tributary of Stomping Creek. So just above, like a couple hundred yards above where Stomping Creek goes into the Greenbrier River down there in Hillsborough. So this is Hillsborough Maple Works maple and sycamore collection in 2014. And you can see basically the sycamore is continuing to produce a few times longer than the maple when you have those warm spells. Essentially, what we're seeing is they're a little bit slower to turn on. They don't produce quite as much sap, but they're a little bit slower to turn off as well. And so where maple is kind of doing these huge fluctuations, sycamore kind of comes up and then it goes down, and then it goes up and then it goes down. And you can see that those gaps in production are from when the temperatures did not get below freezing to achieve that freeze-thaw cycle that is necessary for sap flow. Next slide. So this is 2025, and so Trevor and his family have added another maple site onto this. So they've got 3 maple collection systems and then 1 sycamore. So again, the sycamore is the blue on the bottom, and it essentially kind of stays the same, stays more or less stable, where maple is doing these huge fluctuations that you see like on early March, where sycamore was producing very little, but maple in comparison was producing very, very little. It went from producing 150 to 200 and to 500 gallons to only producing 75 gallons, whereas again sycamore is kind of doing this more level flow. And we had that mid-February gap in production where we just got a hard freeze in this area, and so nothing was producing. Next slide. And this one, so that top graph is the sycamore sap flow in conjunction with the temperature. And so you can see you can see more gradient here with the temperature, but you can just see how it matches exactly just like maple does, that the temperature flow. And then the lower graph is the sap per tap, and that includes sycamore and all of the maple sites. And you can see that there are times when actually the sycamore was it never outperformed the maple, but it was on par with maple a couple times in the season when those temperature fluctuations weren't as great. We were seeing some good production out of sycamore and mediocre production out of the maple. Next slide. Okay, and this is McCoy's Mill, so this is Luke's site. So this upper graph is the total sycamore collection, sap collection at this site in 2024. And again, it matches the temperature data. That's just, we're continuing to affirm that is the case. Next slide. So this is this year, same thing, very similar kind of pattern, that once it turns on, it's more or less staying the same. We had a couple of really high production days, but this is the total production for the mill. So this is both lines combined. Next slide. Going to differentiate. So now we're able to see the 2 separate lines. So the blue line is the 7/16 tap, that experimental walnut tap. And then the orange line is the orange bars are the 5/16 CDL taps. And the only time we're seeing outperformance of the 5/16 taps from CDL is on these really warm days when the tree is just pumping out sap. And what we kind of hypothesize is that essentially there's only so much sap you're going to get out of a tree in the season. And we're seeing that in more gradual amounts in the 7/16 experimental tap versus that 5/16 CDL tap. And so that larger hole, you're getting kind of a more consistent sap flow throughout the season than with the 5/16. And the two lines matched for sugar content. And so that's an important that piece of information as well. It's not like we were getting more sugar content out of the smaller hole. We were getting the same sugar content out of the two lines. Next slide. Again, this is the differentiation of the two in a different visual in comparison to the freeze-thaw cycle. We did we did not have the pump working correctly at the very beginning on the 5/16 tap. But even when we adjust for that, we basically have twice the production over the course of the season out of the 7/16 taps.
Yeah, I would just add that I think it was about 60% more, a little bit over double if you looked at the total yields. But once we took the days out where one pump was running and the other wasn't, the 7/16 really outperformed, did about double the production that the 5/16 did. So just a few notes about the actual final process, because everything we've talked about until now is about collecting it. And folks, anyone who's has been to any of our programs on walnut syrup know that with walnut, we had some additional questions around how to actually boil it down and filter it. And so this is what the overall final product, some notes on that. So this is just, once again, I can't stress the importance of an RO if you're actually planning to make some sycamore syrup. When you can get a range of an average daily collection that can go down to 0.4%, get up to 0.7, it'll stay at 0.7 for days. 1 is going to be the best you see. That RO is essential. As I always tell people, I've got a 55-gallon collection barrel on each line. And once I'm done ROing that, take it up to about 7%, 7.5%, I can put all the concentrate into a 5-gallon bucket. So we're going from 55 gallons of sap down to 5 gallons of concentrate. So that it's just a lot of reduction. So one thing that I do with that when I'm getting, in fact, if you collect for a week and end up with only 5 gallons of concentrate, it doesn't really make sense to try to cook it all down. And so what I do is I end up then freezing it in a deep freezer and boil once or twice a season, and that way I'm doing an actual real boil, making 1 or 2 gallons at a time of final syrup. So just some math on that. In 2024, I collected 292 gallons of sap, and that only ended up being 1.5 gallons of syrup. So if you're a maple producer, you would probably scoff at that and say, what's the point? And I think it's from my standpoint, we just need to change our expectations when it comes to Sycamore. Also, because with the final product you get with Sycamore is a much more robust syrup, to say it. I don't really know another way to say that. And so a little bit goes a very long way, especially if you're blending with it or you're cooking with it. So its final flavor ends up being the lighter stuff. You can see here a picture of it. That's going to be a lighter sycamore syrup, and even that is an amber. And then it gets very dark and can even be black, but still tastes. I've had some very dark sycamore syrup that tasted really good. Sorghum, if anyone's familiar, had sorghum syrup. That is the closest thing I've ever tasted in terms of its flavor profile range. And actually, when we've done taste tests, we see that when we make let people from, say, Kentucky who grew up on sorghum and they try Sycamore, they say that that's amazing. If you like sorghum, you will love Sycamore syrup. That seems to be the general consensus. A lot of people say that it tastes like butterscotch. It does when it's boiling down. That butterscotch flavor, it really, I only noticed it in the lighter batches, or went right before it's actually up to 66 bricks. And so I think maybe with some of these old timers, you say it tastes like butterscotch, they probably weren't taking it all the way to the 66%, which is fine for if you're doing it at home, but you certainly wouldn't want to sell that. Like a maple sap, it definitely sours and bitters as the season goes on. So and it will go bad. So you want to be, as you would with a maple, you want to make sure that you're paying attention to your sap and kind of keeping it separate. And if you have questionable sap, it will sour an entire batch. Because the overall production is so low, we still have a lot of questions about the filtration process. The only way I've been able to filter it is using a cone filter with some, and I always put 2 pre-filters into that. And even then, I still am pulling off in that method a lot of niter and mineral content, sugar sands. I would really like to see what a Sycamore syrup run through a filter press or a more robust vacuum system would, like the quality of it. I think it would clear it up more than any that I've seen. But generally, when you're making such small batches, it's really hard to justify. I mean, in some years, I don't actually have enough to turn a filter press on, let alone justify buying one. We have seen some crystallization in the final product once it's open, kind of similar to the oxidation effect that happens with honey. We're not sure if that actually is a similar oxidation effect, or if that is just the way that overcooked Sycamore syrup crystallizes. I'm glad to say I think the past few years that hasn't happened as much. So it could be something about that it was some of us were getting our sap too hot in the finishing process. So when you're measuring your final product by the fluid ounce, you probably don't want to dump this stuff on your pancakes. It's also a very robust flavor. So instead, where we've seen a lot of uptick in uses are both for culinary or cocktails, using it as a meat glaze or soups. I've given some to some chefs. And then the other area that I mentioned before is mixing it. If you're a maple producer and you've already tapped out all the trees you have, but you've got some sycamore trees, I would recommend you go ahead and you tap those sycamore trees. Because one thing we've seen is if you have a little bit of off flavored maple and you blend it with some strong sycamore syrup, you get a new type of syrup. You get a blended syrup, and that flavor, actually, the sycamore will mask out any off flavors in the maple. And at that point, no one's really looking for, if you, for instance, you have some metabolized maple syrup and you mix it with sycamore, I guarantee you're actually going to make a really good batch of maple more. It actually probably tastes better than if you used on like grade A golden maple for the mix. I always would suggest using a darker maple. And so when we make maple more, which we do here at the university, and it's pretty popular, we don't sell it, but we'll certainly let you try it. We do a 70%, 30% maple split. So going back to our mission of really trying to help create economic diversification through this work, one of my core arguments for why tap Sycamore is that you can basically triple the value of a bottle of maple syrup. If you were to take a pint of syrup that you might otherwise sell for like $8 or $9, I think you could sell that if you were to blend it with Sycamore for upwards of 26. So, and right now, when there are very few people who are making it, there's certainly a lot of market demand. All right. We wanted to just pause. We have a few more slides that to go into on sycamores in general, but we did want to give an opportunity to pause and see if there are any technical questions about the production or research process itself, because we know we just threw a lot of information at you all. But I'm looking here at the chat. I'm not seeing any questions. If you have one, please enter it in the chat. We're gonna keep going with our last couple of slides, and then we'll have another chance for questions at the end if folks want to submit any. So Sarah, over to you to talk about where we're kind of going with this. Where it started with an experiment, it started to become research, and as I like to say, every year that we answer a question, we end up with a whole lot more questions. So what's next?
Yeah, so we have a research partnership that will we've been working with Dr. Yangjin Zhang at West Virginia State University a little bit on sycamore and walnut and maple and the physicochemical properties of these tree syrups. But we have just we'll officially kickstart in June a new project that will dive deeper into this and take the initial findings that we uncovered to the next steps. And so just to draw your attention to the image on the in the upper right there, essentially this is demonstrating the antimicrobial activity of these 3 different syrups. And so we saw some measurable antimicrobial effects of black walnut syrup. There's really not measurable antimicrobial effects in maple syrup. However, every sample that was tested of sycamore had antimicrobial effects. And so that ring of inhibition of microbial growth on the petri dish plates there on the right hand side are just the 2 different Staphylococcus and Pseudomonas is really impressive for a sugar substance to have antimicrobial effects. And so that's pretty exciting and something we want to find out more about. And so we'll be looking at those antimicrobial effects as well as the phenolic content and antioxidant activity of those specialty syrups, including sycamore. And so if you're someone that is producing sycamore and wants to be a part of this research project, I encourage you to reach out to me because right now we have the McCoy's Mill site and we have Hillsborough Maple Works as our partner researcher. And we'd love to include more different sources of sycamore syrup to test them against each other for these properties. We're also, as part of that project, going to be looking at additional value-added product opportunities, looking at defining flavor profiles of these syrups, which again includes sycamore, really honing in on maple more and defining more carefully a sales pitch profile for maple more. And then one thing that Dr. Zhang is producing out of her lab, which is a microbiology lab again at West Virginia State, is freeze-dried products for additives in other food products like yogurts or other fortified foods. So that's pretty cool. And then our other research will continue to look at production best practices and defining those to create an industry standard specific to sycamore. So we're going to continue to research tap sizes, basically confirm the data that we produced this year at the McCoy Mill site. And again, if you're a Sycamore producer, I encourage you to reach out to me. We love to have partner producers as much as possible and increase our data, the base point of data collection. And then the thing that we really need to look at is about the creation of non-conductive wood in sycamore. So in maple, the value of sap collected versus volume of non-conductive wood created by larger taps, the volume of sap collected did not outweigh the volume of non-conductive wood created. And so what that essentially non-conductive wood is the scar tissue around a tap hole that is created as a tree heals itself. And so given the tree physiology of sycamores, we're curious to see if the larger tap actually impacts the longevity, the future tapping potential of sycamores. And because of that fast growth rate, we actually speculate that a smaller amount of non-conductive wood is created, and that the circumference of the trees, the growth rate of the trees, will allow us to have that, even if there is more non-conductive wood generated from tapping with a larger tap hole, that that the growth rate is so fast, especially in these in like more southern central Appalachia, the more southern reaches of the syruping world, that the by the time, if you tap here and by the time you get around the circle to tap back essentially at the same place a number of years later, if you follow a specific tapping pattern, that that it the greater volume of non-conductive wood will not impact future tapping potential. And then, as Luke mentioned, one of the things that we really want to research more is about filtering the finished product, because we have that that quandary of the sediment and kind of crystallization that's happening in the finished product. And one of the things that is interesting about some of the future research that we're wanting to do is it actually ties back to known traditional medicine and ethnobotanical value of sycamore, from native peoples or indigenous peoples in this region and north and into the Midwest. So that's including Cherokee Creek, Delaware, Iroquois, and Meskwaki indigenous peoples. And so it is documented that those peoples were actually using sycamore leaves and inner bark as a traditional medicine. And they would create infusions or decoctions, so like teas from the inner bark and roots. And then they were used to create or to cure or as treatment for respiratory illnesses and other bacterial infections. And so that just, it really references what we're seeing in that microbiology lab research. And it's really cool to see those parallels come together. Medicine that was traditionally used, and then now that we have the science to prove prove what's behind those things working. And then there's also recently been some clinical studies in using kind of more modern Western medicine practices of compounds made from the sycamore leaves and the inner bark. that is an effective treatment of MRSA. And if you don't know, MRSA is the resistant staphylococcus. MRSA is like a real problem. Basically, it's it's a microbe that is resistant to antibiotics, and you can get a MRSA infection from anywhere, but it's really a problem in hospital and other care settings when they have an infection, a bacterial infection that's resistant to antibiotics. And so if we can find these new compounds that can help as an effective treatment for those resistant microbes, that's really, really great. Next slide. And now to go to a completely different train of thought. I always like to include, if I can, if I know them, what I classify as useless or trivia winning facts about a certain subject. And in this case, we're talking about sycamores. And so one of the most famous sycamore trees in our region is the Pringle tree. And there were actually a pair of brothers that deserted their post with the American or with the British Army during the French and Indian War. And they traveled down the Tigert Valley to Buchanan, and they found a massive tree in Upshur County, and it was hollow, and they basically lived in it for 3 years. And then that tree became the site of the town, or 2 miles away, a mile and a half away from where that original tree was, is where the town of Buchanan was created. There is now a park, and at that site is the third generation sycamore, which is a descendant of that original tree, is still growing, and it has a historic marker there. And it was basically one of the first permanent settlements west of the Alleghenies in what was then the state of Virginia, or the Commonwealth of Virginia. And then some more useless trivia. Sycamore was among the species that were, the seeds were sent up with Stuart Roosa, who was a former smoke jumper for the Forest Service, and he became an astronaut. And in partnership with Ed Cliff, who's the chief of the U.S. Forest Service at the time in the 70s, they had decided to send a whole packet of seeds to orbit the moon on the Apollo 14 mission. And so Stuart Roosa took this packet of seeds up, and they traveled around the moon. They circumnavigated the moon and then came back. And it was the question that they were trying to answer was, does it impact the seeds if these trees, or does it impact the trees if these seeds have left Earth's atmosphere and then returned? They basically found out that there were still viable seeds. Unfortunately, initially where they were grown was not a nursery that was outfitted to grow tree species, and so they grew a lot of the seeds, and then the plants died after that, but it was because of lack of care. And then they were sent out to a number of Forest Service stations, and the remaining sycamore seeds were sent to Gulfport, Mississippi, and then those trees were grown out and actually distributed as part of the 1976 bicentennial celebration of the U.S. And so the tree species, the seeds that were sent up to space were sycamore, loblolly pine, sweet gum, redwood, and Doug fir. there continue to be trees that are grown from these seeds or cuttings from the initial trees that were grown. You can still get them if you really want to. They're available from American Heritage Trees in Tennessee. And the picture on the lower right is in Friendship Park in Stuberville, Ohio, and that is one of the bicentennial trees, also called a moon tree. That ends my useless and trivia winning facts.
Well, thanks, Sarah. And so do we have any questions?
Yes, there is a question in the Q&A box.
Oh, this is a good one, and it's a Sarah question. So, are there different varieties of sycamore, and is there any known species like the difference between the maple varieties?
So, there are different kind of sycamore species. However, anything that you're going to find in the US pretty much is Platanus occidentalis. So there is Platanus or sorry, I'm blanking on the Latin. There is a European tree that is related to the sycamores that are found in the US. But basically everything you're going to find in the US is going to be Platanus occidentalis. And whether you're buying, there are some, and I can grab my book from downstairs. There are a few cultivars. So within that same species of Platanus occidentalis, there are a few known cultivars that have been developed in the nursery industry. Rarely, though, is sycamore a species that is used in is grown out in commercial nurseries for intentional planting. And so it does not have the species or the cultivars like maples are.
Great. Thank you, Sarah. If anyone has any other questions, please feel free to put those in the chat or the Q&A, and we will get to those. Casey, if you want to go ahead and launch our exit poll, we can go ahead and take care of that right now. Thank you, Luke, and thank you, Sarah, for being here with us this evening. That was a ton of great information about what's happening with the sycamore syrup here in the state of West Virginia. I have added some information to the chat. So if you do want to get some more information about sycamore syrup, there is a link in the chat that will take you to sycamore sap and syrup field trial that was written by Dr. Mike Recklin. Or if you just want to check out some of our resources in general, we have a ton of syrup resources, and the link is in the chat as well.
And
our next, go ahead.
I'll chime in to say that following that same link is for our resources is a white paper specifically on sycamore, its variable uses, and about producing sap and syrup from sycamore trees. And that's called white paper is adding farm value to Appalachia's riparian buffers, preserving existing sycamore trees.
And I am putting that link in the chat right now.
You can read more information about my useless trivia facts in that white paper.
And just as a reminder to everyone, our next Out of the Woods is May 15th at 7 p.m. We'll be joined by Dr. Joey Alloy, and he will be discussing agroforestry, our programming here at the university, and our new resource database that we will be having available in the coming months. So if I don't see any other questions, I think we can wrap things up for the evening. Thank you, everyone, and we will see you next month.
Thanks, everyone. Have a great evening.